more microbes on us and in us than there are us. They are us and we are them. Nobody gets out of here without them. I say it's a conspiracy. Human beings are nothing but vehicles to move microbes around because, remember, 25% to 30% of manure, including our own, is microbes. That's how they get around. That's why you have those seeds, 100 pounds of clover seed eaten by cattle to spread seed with that biological inoculant called manure. Fertility and microbes with seed. That's how there's a, and it's true. Plants have conspired to be disseminated, and microbes. The microbial biomass is unbelievable. I consult for golf courses even though I never picked up a pair of golf clubs in my life. And the reason why I do is because, my son's a greenskeeper. And I also work with another company that I founded and left years ago called Earthworks. And we are in the process of getting these golf courses unaddicted to poison. Because I'll tell you what, these things are basically Superfund sites. There's about 16,000 golf courses in the United States, and you take the average private country club that's well endowed with money, and their fungicide budget alone on an 18-hole course, which is about 125 acres, is $40,000 a year. That's a lot of fungicide on 125 acres. And that's because they've got no diversity. And their sand greens and sand teas are 90% sand, so it's Florida, right? 10% peat moss. They deliberately make them that way. So the biology is kaput. With a monoculture with lots of nitrogen. Perfect remedy for a fungal explosion. You've just created the perfect storm for a fungal explosion. Nitrogen, no biology, and monoculture, no diversity. Kaboom. So now you've got to spend $40,000 a year, which the chemical companies love, to keep this looking this way. But even there, even on golf courses, they know air is critical. So they aerate. That's an aerating machine. They aerate. Because they have these livestock that weigh about 250 to 300 pounds to get up there at 8 o'clock in the morning every morning, swinging the balls. And, they have these golf balls, and for good luck, they pick that ball up and they kiss their balls. Right. Pun intended. So you can see that this golf course is nothing but, that's not Bahia grass, and it's not bent grass. It is bent grass, not Bermuda grass. They use Bermuda grass out west in the wintertime. And ryegrass. But this is bent grass. That's it. That's the whole course. But when we go to agriculture, that's what we have in agriculture. I contend to you that this slide has got more diversity than that slide.
That's right.
And that's our food-producing slide on soil. That's the San Joaquin Valley in California where most of our food in the United States comes from. This desert-polluted valley. And 1 pound of food now costs 6 pounds of lost topsoil. That's what our equation is. That's pretty bad. So diversity versus monoculture. This guy here, if you ever see anything by him, Dr. John Todd, University of Vermont, Ocean Arcs International, patented a system called the Living Machine, a waste remediation system for sewage treatment plants, industrial waste, you name it. And what he's got is that. And what you see here are cells. Now this is in a industrial facility. And what you see are individual cells, and each cell is an ecosystem. When the waste goes into the first cell, it's primitive life that's in there, algae and bacteria. And then it spills over into the next cell, and the life forms become more complex. And then it goes into the next cell, until finally you get down to the lower cells, and what do you see? Higher plants, snails, very sophisticated ecosystems. So it starts out primitive, where the waste is really toxic. And as it goes down, the ecosystems become more diverse. And when the water finally comes out the back end, the water is potable. Because biological systems have abilities to purify water unlike mechanical systems do. Now he's putting these in Superfund sites like the Tennessee River. They have a 5 mile, EPA didn't want to do it. They tried it, proved that it worked. They have a 5 mile toxic sludge deposit along the Tennessee River that they were talking about digging up and taking to a hazmat landfill. That's a good idea. And you stir everything up, and all that stuff that's in the sludge becomes vaporous, and all the neighborhood gets to inhale it. That's real good. He showed how you can just siphon it out over here and dump it back down here and just remediate the whole system. Turn it into potable water. The water's cleaner than the water that's in the river above the site. That being said, what's the point here? Well, all of those cells have ductwork that are connected to each other. And why is that? Because every cell wants to know what the other cell knows. And by biological communication, remember, we're communicating. How do we communicate, by the way? Does anybody know at the cellular level how we communicate? We communicate with light. Photonic emissions. All cells, all substances emit photons. And those photonic emissions are basically Morse code or light communication emissions that tell other cells what the problem is, how to boot up, how to get ready. And so all these cells are talking to one another. And so when you look at the whole microbial biomass on the face of the earth, 50% of the entire biomass of the planet is microbes. Up to 50%, if you think about it. There's more microbial cells on Earth than possibly stars in the universe. 80% of all biodiversity is microbial. There's more microbial cells, as I said earlier, in us and on us than there are us. So, now we get into form. And I talked about fractal geometry. And I'll talk about this because if you think about fractal geometry, this is the Koch snowflake. You start out with a triangle, you put one on top of the other, and you get David Star David. And you keep doing that, and you end up with this snowflake. Just taking triangles and overlaying triangles, you get this surface area. Anybody ever been to Maine? All right, so if you're driven from Portland all the way up to New Brunswick, a straight line on the highway on Route 1 or 95 is 300 miles. If you were to drive along the actual coast, rough line coast of Maine, every inlet and outlet, you're at 3,000 miles. That's called surface area. That's if you're a human. What if you're a mouse? It's even farther. Not because you're small, but because your surface area interfacing with the shoreline is more detailed. What if you're a microbe? See how it keeps getting larger and larger and larger, how you create this infinity, this fractal infinity within finite areas. What's the importance of that? Well, when we get to life forms, this is a root here, and you can see that the mycorrhizal coats it like a green film, but this is just one tiny root here of those 6,000 miles of roots on one annual plant. So you can see how nature can create this unfathomable, almost unthinkable amount of infinity within a very, very small area. And that's important to understand why microbial systems are so efficient and why we need them so desperately, why we can't keep destroying them. Now here's the villi of the small intestine. And when you look at that, look at the surface area there. Now, the one on the left is damaged, the one on the right is healthy. You can see the difference. You can see the bloom on the one on the right-hand side. And it's really important to understand that those villi then are also encased on the top with what we call microvilli. And what's going on with the villi is that this is a vascular organ that is a habitat or an ecosystem for 60 to 80% of the immune system. And down in the crypt, in the trough, is what we call the VDRs, the vitamin D receptors are down in there. And we now know how incredibly important vitamin D is. You know, I always say, don't ignore the elephant standing in the room. It's not coincidence. It's not coincidence that sunlight gives you one of the most